Alright, so I wanted to finish up the video I did on, proving that this is true, the 1 equals 0.999 repeating. And so I talked about, before I talked about, that 1/3, if you equals 0.33 repeating, if you multiply both sides times 3, you get 1 equals 0.99 repeating. And then I also talked about sort of the fact that there's no distance between these two numbers, and therefore they have to be the same number. And I wanted to show you another one of my favorite ways, just because I feel like this is a way that most people can do, and not that you couldn't do the other ones, but this one is, most people have dealt with averages. So, for instance, let's say you took 2 tests and you made an 80 on one test, and then you made a 90 on the other test. Okay, and I said, well, what was your test average? Most people automatically would say, well, the middle between these two numbers is 85. Okay, so my average was 85. Okay, so most people know when you average two numbers, it's somewhere, it's the middle of those two numbers would be your average. Another way to do that would just be to take 80 and add it to 90 and then divide by 2. That would give you the same thing. Okay, and so this would also give you the average of 80 and 90. You would end up getting 170, and then 170 divided by 2 is 85. Okay, and so finding the average tells you what's in the middle. Okay, so what is in the middle of these two numbers? Okay, and so I want to show you that with 1 equals 0.99 repeating. Okay, so we're going to average these two numbers. So to do that, again, we need to add the two numbers and divide by 2. So we're going to do 1 plus 0.999 repeating. Okay, and then we're going to divide by 2 and see what we get. Okay, I'm going to scroll down just a dish. Okay, and so first thing we need to do is add these two up here. Okay, so 1 plus 0.999 repeating is 1.99. And again, excuse me for my writing. I'm trying to do this with my mouse and I don't always do a great job. And then I need to divide by 2. And let me actually scroll down a little bit, because let me rewrite this. So actually, let me make sure you can still see that. So again, I'm gonna do 1, and let me do it in a different color here. 1.999 repeating, and then we're going to divide by 2. Okay, and if you remember when you divide, oops, sorry, we're going to make that big dot now. You need to bring that dot up here. Okay, so can 2 go into 1? No, but can 2 go into 19? Well, yeah, how many times? Well, 2 can go into 18 9 times. 9 times 2 is 18. Subtract, and we get 1. Okay, and we bring down the 9. Again, 2 goes into 19 9 times. 9 times 2 is 18. You may begin to see a pattern. Subtract. Get 1. Again, we're going to bring down the 9. And as you can see, we're going to keep getting 19 here. Okay, so we subtract 18, we get 1, we bring down the 9. Again, 2 goes into 19 9 times, we get 18, subtract, get 1, bring down the 9. We're going to keep getting the same thing. So what we're going to end up getting is 0.99 repeating. Okay, now that's interesting because the two numbers we're averaging are 1 and 0.99 repeating. And so when we find the average of these two numbers, our average is one of the numbers. Now the only time that happens is if those two numbers are the same. Okay? And this really goes back to what we talked about in the other video, was there is no number between these two numbers, and because of that we know they have to be the same number. And this is kind of saying the same thing, because this is saying that the number between those two numbers is one of the numbers itself, which basically just tells you that they have to be the same number. And another way to look at this, so let's say we made these like variables. Okay, so let's even look at this kind of algebraically. If I took 1 and 0.99 repeating, let's call 1a. So let's do this kind of a little more algebraically. And I'm going to scroll down here. Okay, just to kind of show you that they have to be the same number. Let's use this color here. We'll use purple. Okay, so let's say 1 is a, that 0.99 repeating is b, and we divide it by 2. And what was our solution? Well, we said our solution was b, okay? So when does that happen? Well, let's go ahead and kind of manipulate this equation here. Well, if I multiply both sides by 2, sorry, that was kind of a bad way to write that, but hopefully you kind of get the picture. So I multiply, this goes away, and I get a plus b equals 2 times b, but 2 times b is the same thing as b plus b, okay, because b plus b is 2 b's. Okay, hopefully you follow that. 2 times b is nothing more than just saying b plus b. And so here, I can actually subtract b from both sides. Okay, so I'm going to subtract, let me undo that. So I'm going to subtract b from both sides. Okay, that goes away. That goes away. And what this tells me is that a equals b. Okay, and so because we have shown that the average of these two numbers gives me one of the numbers, which we in this case called b, it proves that those two numbers have to be the same. And again, it goes back to what we said before when we talked about the fact that, and I'll scroll all the way back up here, is that there is no distance between these two numbers. Okay, and because there is no distance between these two numbers, then the two numbers has to be the same. Okay, and I like this problem because, well, I like it because I had never seen it before up to this point, and again, I was in college when I first saw this, and it shows so much about math that we don't learn until we get to calculus. So for instance, it shows that 1 can be represented as an infinite sum. And let me just show you what I mean by that. Let's see, I don't have room up here, so I'm going to try to show you in this little space here. Hopefully it's not too complicated. But we're showing 1. 1 is a finite number. It's the most basic of numbers, but it can be represented as an infinite sum or an infinite series. And just to kind of show you what I mean by that, we're saying 1 equals, okay, 0.9, okay, this first 9 here is the same thing as 9/10, because this is 9 in the tenths place, okay, so we're showing that 1 equals 9/10, plus the next one is the hundredths place, so this is like 9 over 100, plus this 9 here is in the thousandths place, so it's like 9 over 1,000. Again, forgive me for my sloppiness. Plus, you know, so on and so forth. Okay, and so in calculus, you learn about infinite sums and things of that nature. And what I love about this is if we were to teach students this truth early on, and so most students kind of, even early on, even in elementary school, kind of understand the concept of something repeating infinitely, or at least they kind of understand it, in middle school even more. But if we were to somehow connect these two, okay, to sort of show this and show students that this is something that is actually possible, at least to get that in their mind, then calculus wouldn't be such an alien to us. And I think that's actually, I think calculus is such a beautiful subject that, you know, it's sad that most people don't get to see it, but, or a lot of people, not most, but, and this right here is such a cool truth that you see in calculus. The infinite sum, somehow you can add an infinite amount of numbers, and somehow that gives you some finite number that, you know, to most people doesn't make a lot of sense, or to some people doesn't make a lot of sense. It's like, what, that doesn't, you know, how can something infinite be finite? You know, it doesn't, you know, how could that be? But I love that it is, and we sort of learn a lot about that through this truth, and I think that's why I love this truth, because it has so many aspects to it that can open up so many doors to our understanding and at least appreciating, as I said in another video, the beauty of math. Okay, numbers are so cool, and they have so many truths in them that it's just fascinating. Okay, anyway, I hope you enjoyed this. It is true. This is not an opinion, that 1 equals 0.99 repeating. This is true. This is mathematical fact, and it's so beautiful because, again, if you go to infinite sums in calculus, you're going to find that this sum does equal 1. Okay, and hope you all enjoyed it, and hope your passion and appreciation for math has grown exponentially.